JEE Advanced 2025, Paper 2, Physics, Question 1. A temperature difference across a material can generate an electromotive force. This is called the thermoelectric effect or Seebeck effect. Here, S is the Seebeck coefficient, sigma is the electrical conductivity, and kappa is the thermal conductivity of the wire material. The question states, a temperature difference can generate EMF in some materials. Let S be the EMF produced per unit temperature difference, sigma the electrical conductivity, and kappa the thermal conductivity. We need to find the dimensional formula of Z equals S squared sigma divided by kappa. The four options are A. M0 L0 T0 I0 K0, meaning dimensionless. B. M0 L0 T0 I0 K to the minus 1. C. M1 L to T minus 2 I minus 1 K minus 1. D. M1 L to T minus 4 I minus 1 K minus 1. Let us recall the key dimensions. The Seebeck coefficient S is EMF per unit temperature difference, so its unit is volts per Kelvin. Electrical conductivity sigma is the reciprocal of resistivity with unit 1 over ohm meter. Thermal conductivity kappa measures heat flow with unit watts per meter per Kelvin. We need to express each in terms of fundamental dimensions M, L, T, I, and K. Now let us find dimensions step by step. Step 1. The Seebeck coefficient S equals voltage per temperature. Voltage has dimensions mL squared T to the minus 3 I to the minus 1. Dividing by temperature K, S has dimensions mL squared T to the minus 3 I to the minus 1 K to the minus 1. Step 2. Electrical conductivity sigma is reciprocal of resistivity. Resistivity ρ has dimensions mL cubed T to the minus 3 I to the minus 2. So sigma has dimensions m to the minus 1, L to the minus 3, T cubed, I squared. Step 3. Thermal conductivity kappa has dimensions mLT to the minus 3K to the minus 1. Step 4. Now we compute Z equals S squared sigma divided by kappa. S squared gives m squared, L to the 4, T to the minus 6, I to the minus 2, K to the minus 2. Multiplying by sigma, we add the exponents. M becomes 2 minus 1 equals 1. L becomes 4 minus 3 equals 1. T becomes minus 6 plus 3 equals minus 3. I becomes minus 2 plus 2 equals 0. K stays at minus 2. So S squared sigma equals mLT to the minus 3K to the minus 2. Now dividing by kappa, which is mLT to the minus 3K to the minus 1. All M, L, T cancel out perfectly. For K, minus 2 minus parenthesis minus 1 gives minus 1. Therefore Z has dimensions K to the minus 1, which is M0, L0, T0, I0, K to the minus 1. The correct answer is option B. The dimensional formula of Z is M0, L0, T0, I0, K to the minus 1. This means Z depends only on the inverse of temperature. All other fundamental dimensions cancel out completely. Here are some important tips for JEE Advanced. First, for thermoelectric quantities, always derive dimensions from base units of voltage, resistance, and power. Second, the Seebeck coefficient S equals voltage per Kelvin, and this is the most tested thermoelectric dimension. Third, when computing ratios like S squared sigma over kappa, expect significant cancellation. Always check if the result is dimensionless or nearly dimensionless. Fourth, remember that electrical conductivity sigma involves current squared in its dimensions, while thermal conductivity kappa does not involve current at all. This distinction is frequently tested in dimensional analysis problems. If you found this solution helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next video.